So the way this works, if this is your first live session, all of these notes that are here on the screen, I mean, we're going to do a bunch of problems tonight, y'all. We have 11 problems that we're going to do: geometry, proportions, and dimensional analysis. So all of this stuff that you see tonight, like when we get to a long word problem, do not try to copy down these word problems. I'm going to post these notes over in the group as soon as I'm done, so you'll have instant access to everything that you see here. In all honesty, treat this like the real TEAS test. Obviously, you're not going to copy down the whole problem on the TEAS test. You're going to start doing some chicken scratch, right? So that's what I want you all to do tonight as we go through this session. Now, this session is interactive, and what do I mean by interactive? You do see a timer up here, and the average amount of time that you have is 1 minute and 30. Let me clear all this junk out. So the average amount of time that you have per question on the TEAS test is 1 minute and 30 seconds. So what y'all can see on the TEAS 7, if you didn't know, it is different than the TEAS 6 for a couple of reasons. I'm sure most of y'all have seen some videos talking about this, but 38 questions and there are 4 ungraded. Now, if you've never taken the TEAS, there is no way for you to know which ones are graded and which ones are not graded. So we need to treat all 38 questions as if it was one of the graded ones. So if we take the 57 minutes that you have, this is how long you have on the new TEAS. If you take 57 minutes and you divide it up into 38 questions, this is where I'm getting 1 minute and 30 seconds from. 1.5 minutes. So 1 minute and 30 seconds. Now, I am not going to go over all of this stuff that you see here on the screen. You will get these notes, but a couple of things that I do have. If you haven't been to my website, please go to my TEAS website. It's everything that I have available. I do have a workbook. A new update is coming soon. I've made several updates. Try my free sample quiz. Try my TEAS 7 math review. That right there has 180 questions right now. When I first created this back in 2020 during the pandemic, I started off with around 80 questions. So over the course, of about a year and a half, I've added 100 more, and those updates are constantly coming. Now, mini classes, you'll see that link there when you get these notes tonight. I know I have a bunch of stuff. I know I have a bunch of videos. So that link right there, let me just pull up my website, because I imagine we have some new people in here. So if I go to bcraftmath.com/ATITs, this is my TEAS website. Now, a lot of people say, hey, you got a lot of stuff. Where do I begin? And look at the first thing that I'm moving right there. It says, are you just getting started? Look at those eyeballs. If you hover your mouse or you tap on it, click on that link. It's a very short video on how to utilize my resources. And then to take away that anxiety of being overwhelmed from seeing so much stuff, look over here at this one. Look at what this one says. What is available with the magnifying glass? If I tap on that link, this is a condensed version of everything I have available. And y'all, I would say 90% of what I have is free, just like this session that I'm doing with you all tonight. So that's my website, all of my stuff. And I will show you one more thing. It's mentioned in the video. If you are working on a particular topic, say, for example, you're working on equations. I know a lot of people who have been out of school for 20 plus years. Mixing numbers and letters in a math problem can be challenging. So on any MacBook, if you hold Command plus F, and this is at the top of my website, or on a Windows or Chromebook, it's Control plus F. Now, if you're on an iPad, tablet, or some other device, you'll have to do a different type of search. But if I do that up here, it pops up a search bar. And this works on any website. Any website, Facebook, or some other person that you're getting some resources from, any website. And if I type in the word equation, this is going to highlight that word equation everywhere on my website. So instead of you scrolling for hours or whatever trying to find something, look for the keyword, and you can even cycle through those keywords and it automatically just jumps through my website and it highlights every time it sees the word equation. Now, the majority of these blue links that you see here, all of these are videos. So it will take you to YouTube where you can watch a video. But I recommend, stopping at my website to look for the resources, type in those keywords to find those videos much faster. I use this search feature on tons of websites when I'm looking for keywords. But I know what you all are here. It's Saturday night. Thank you all so much for joining on a Saturday night. We have 70 people in here right now. I'm pumped. I love it. So, tonight's topics: geometry, proportions, and dimensional analysis. We will be in here longer than an hour. So, get you a drink, pop you some popcorn, do something. If you want to leave, that's fine. But we're going to be covering some very useful stuff. And one of my goals tonight, after geometry, one of my main goals is, if you've heard of dimensional analysis, but you've always been kind of hesitant to use it, my goal tonight is to try to convert as many of you as possible to maybe liking the idea of doing dimensional analysis. And as a matter of fact, you can actually do dimensional analysis for any problem that you solved with a proportion. I'm going to tie all of that in together tonight with you all. So here we go. First thing, geometry. I'm going to mute myself. This is a fill in the blank. Pay attention to the instructions. And again, feel free to submit your answer in the chat. Let's go ahead and get started. All right. So check it. Y'all, the answers are flying in. I love it. So a couple of things here. The correct answer to this problem is going to be 153.9. Now, I saw some 153.86 or 154, and you're doing the work right, but you have to be careful if you have these fill in the blanks. Make sure you round to whatever it tells you to round to, because if you did that work right and you typed in 154 or whatever, if it's not 153.9, it will be counted wrong. There is no partial credit there. So let's go over a few things here about circles. Now, I'm not going to draw pictures of a lot of these. I do have plenty of videos on circles, but since we know the diameter of this circle is 14 feet, and we want to find the area of this circle, you need to know your formulas for area. Now, you could get a test with 2 or 3 circle problems. You might get a test with no circle problems. But I know circles are up there. They've always been up there. All right, so area of a circle. Now, let me go ahead and give y'all a way to help you remember these formulas. I'm going to say cherry pies delicious. And then I'm going to say apple pies are 2. Cherry pies delicious, apple pies are 2. This right here will help you remember your 2 formulas for a circle, the 2 important formulas. Now, even though we're not going to use cherry, this is circumference. Circumference, that's what that C stands for in cherry. Circumference is equal to pi, and the word delicious stands for the diameter. This is a way to help you remember the formula for circumference. There are other formulas for circumference, but I'm going to stick to this cherry pie thing. Now, we don't need that for this problem, but I wanted to go ahead and share it with you anyway. We might use it in a minute. Apple pies are 2. This is the formula that we are going to use. Apple stands for area. Pie, and then notice I put the words R in quotes, or the word R, that's our radius, and 2, that should be in quotes as well. We want to square this radius. We don't want to multiply it by 2, we want to square it. Again, just a way to help you remember those formulas. These will not be given to you if you have a circle problem. You will be expected to know these. So back to this question, it says, what is the area of the circle? Since it's asking for area, I'm going to go ahead and write down my formula. Apple pies are 2. Now, we need the radius, and something you need to go ahead and remember is if you know the diameter, if the diameter is 14 feet, automatically, the radius is half of that. The radius is always going to be half of the diameter. And that's what we want to plug into this formula. So we're going to take that 7, that is our radius, we're going to plug that into here. Now, we have our formula, area equals. Now notice what it says for us to do in this problem, y'all. This problem, it says use 3.14 for pi. So I'm going to replace that pi with 3.14. And r squared, we're going to multiply. And we want to multiply by 7 squared. There's our radius. Now on the TEAS calculator, you do not have a square button. You do have a square root, but you don't have a square button. So what we'll have to do here on our calculator is to take 3.14, and some of y'all might multiply by 49, which is fine because technically that is 7 squared. But regardless, 3.14, you could say times 49. I'm just going to type in times 7 times 7. And I'm going to copy this over to our notes. So I see the 153.86, and now we want to make sure we round to the nearest tenth. So this is why we're going to get 153.9, because that 8 is in the tenth. That first spot to the right of the decimal. This first spot to the right of the decimal is the tenths place. And that 6 tells that 8 to go up, because that 6 is 5 or higher. 153.9 is our final answer. Fill in the blank. You will, if you have fill in the blanks, you're probably going to have to do some type of rounding unless you get whole numbers. Make sure you pay attention to what the question is telling you to do. Now, feel free to come in anytime with questions. I am monitoring the chat. But what we're going to go ahead and do is we're going to just go right on forward with the next one. It's another circle problem, minute and a half. Try this one out. Okay, so I am seeing a bunch of C's coming in, and it's the same question, y'all. It's asking the same type of information. Notice we are given a diameter. Our diameter is 24 inches, and it's asking what is the area. So since the question says what is the area of the circle, apple pies are 2. Now, if you look at your answer choices, notice the pie is still hanging out in the answer. So this is where, and this is not going to be a fill in the blank. If you have to use pie, you can't type in a pie on the TEAS test. This is going to be a multiple choice question if you left pie in the answer. And that's exactly what we're going to do. Literally, I'm not going to mess with pie. I'm going to let it hang out right there. So since we know our diameter is 24, diameter is 24, that means our radius is half of that. So the radius is 12 inches. We plug that 12 just like we did a while ago. And now we want to square that. Leave pi alone since every single answer has a pi in it. And we multiply by 12 squared. And that is where the 144 is coming from, because 12 times 12 is 144. And the most common way you'll see it is you'll see that written in front of pi if you ever have this type of question. And I'm just going to put a few notes down here. So now, I did see an answer. Now, if we did, let's suppose we did go and use 3.14. If I take 144 and multiply it by 3.14, we're getting 452.16, and that would be the answer if you did use 3.14 for pi. But again, since pi was in the answer, we don't touch it. We let it hang out. It's just part of our answer. All right, so apple pies are 2. That is what we use for the area. Now let's bring in some cherry pie. How about that? This is number 3, minute and 30 seconds. Try it out. All right, so we're reinforcing that idea of pi being in our answer. A is correct, very nice. Now, if we did use 3.14, which we don't want to, then yes, you would get a different number. Now, 2 things going on here. We're given the area of a circle, and it's 64 pi square meters. The question says, what is the circumference of the table, or the circumference of the circle? And by the way, y'all, circumference is just a fancy name for the perimeter of a circle. That is all, that's what circumference means. It's just the perimeter of a circle. Like now, if you think about the perimeter of a rectangle, you add up all 4 sides. The perimeter of a triangle, you add up all 3 sides. You can't add up sides on a circle because you don't have straight sides. So many, many, many moons ago, they gave it this funky name, circumference. It's the perimeter of a circle. Now, we cannot answer this question yet. Cherry pie's delicious. Because we don't know the diameter. Well, that's where we have to go back and maybe use some additional information. So what do we know? We know the area. We're given area equals pi r squared. Apple pies are 2. And we are given the area. We know this area is equal to 64 pi. So I'm going to replace that A with 64 pi because that's what that sentence says. The area is this thing. So we're actually going to do just a little bit of algebra. We need to solve this equation. Let me bring down my formula. Pi's are 2, pi r squared. And we need to solve this equation for the radius. And once we find the radius from here, we can use that or we can double it to get the diameter, and then we can answer our question. So it's like a multi-step geometry problem. Now, maybe you know this, maybe you don't. But what 64 pi means, it means 64 times pi. What pi r squared means, it means pi times the radius squared. My point here is this. If we divide the opposite of multiplying by pi, I'm going to divide by pi. And by us doing this on both sides, the pi's are vanishing. They are canceling out. Let's bring down what we have left. We have 64 equals our radius squared. Now this is actually a nice radius. Now remember, do not divide by 2. That is not, we're squaring. The opposite of squaring something is to take what's called the square root of both sides. And I do want to show you this on the TEAS calculator, or my calculator. And let me just load up. This is just a picture. If you have not seen the TEAS calculator before, this is the TEAS calculator. I don't even worry about those buttons. Take my word for it. I've messed with calculators all my life, and I've never really messed with those. You can learn them if you want as some type of memory buttons. But if we look at everything else beneath there, this button layout is pretty much the same layout that I have over here on my calculator. Again, don't worry about the memory buttons or whatever they are. Let me show you how to take the square root. Now, why do we want to take the square root? And some of y'all probably already know that 8 squared gives you 64. Well, here's how you take the square root on the TEAS test. Type in whatever number you want to take the square root of, and then right beside your decimal, the key will not look identical to what you see there, but it's the square root button. It's a little check looking thing. If I press that, it will take the square root and we get a radius of 8. Now I'm gonna come back and practice with the square root again with you right here in a moment, but for now, let's go ahead and finish this off. So our question from a few moments ago, what is the circumference? If our radius is 8, That means our diameter is going to be 16. Let's plug that into D. That's what the D stands for, delicious. So therefore, circumference is equal to pi times that 16, the diameter. And the most common way you'll see this, notice pi is hanging out in our answer. I'm just going to put the 16 up front. This is our solution. A is correct. So before I go to the next question, let's just talk about square roots a little bit more. Come on in on the chat. What is the square root of 36? 6, right? It's not 18. So the square root of 36 is 6 because 6 times 6 gives you 36. What is the square root of 49? 7, yes. So now, sometimes you got funky square roots. If I pick any number in between 36 and 49, it's going to be 6 point something when I take the square root of it. For example, look, let's take the square root of 37. That's ugly, but I know it's going to be just a little bit bigger than 6. The square root of 36 was 6, so the square root of 37 is going to be just a hair larger. Type in my 37, bang on that square root button, and notice it's barely over 6. And if I were to come and get closer to 49, let's say the square root of 48, that's really, really close to 49, but it's going to be just under 7. So 48, tap the square root, we get 6.92 blah, blah, blah. Do y'all see what I'm saying here? That's how square roots work. So if this was a fill in the blank or something, make sure you pay attention to the rounding. Square root of 50. I'll just do one more and then we're going to move on to the next question. Square root of 50 is not 25. We are not dividing by 2. This is going to be just a hair larger than 7. Just a hair larger because 50 is bigger than 49. So if we do the square root of 50, notice it is just a little bit bigger than 7. So there's your square root button on the TEAS calculator. All right, a little bit more geometry. We are going to move on to triangles. And this one here, fill in the blank. We'll do a minute and 30 seconds. Try it out. All right, so right triangles. Right triangles. Blast from the past, a squared plus b squared equals c squared. More than likely, if you are given a problem, and by the way, there was a couple of, well, I do see, okay, the same person submitted it twice. 21 is the correct answer, 21 centimeters. Now, if this is fill in the blank, we don't have answers to go off of. So we need to be able to do a little bit of, maneuvering or solving some equations. So, keywords here, right triangle, more than likely, you're going to need to use what's called the Pythagorean theorem. Now, don't stress about that name, but I'm going to put it up here because if y'all want to look up videos later, whether it be my videos or somebody else's videos, Pythagorean theorem is what you will see, and this is referred to as a squared plus b squared equals c squared. Now, I do want to give you a picture here, because we didn't get a lot of correct answers, and I want to show you what in the heck A is, and B is, and C is. So, I'm going to draw a right triangle. Now, it's not necessarily going to be to scale, but here's our right triangle. And for it to be a right triangle, technically, you got to see that right angle there. That is a common little marker when the two sides form a right angle. That's a 90-degree angle. Yes, I do see that coming in over here on the chat. So that 90-degree angle, the two sides that make this right angle. This side makes the right angle, and this side makes the right angle. Now, it does not matter which one you call A and which one you call B, but one of them will always be A and the other one will always be B for this Pythagorean theorem. Now, they do have another name too, y'all. Sometimes you will hear these referred to as the legs of your right triangle. But what you must remember is that the A and the B, the things on this side of the formula, are the two sides that make the right angle. So, what about this third side? This side does not make the right angle. Well, it's our only other letter. It is the letter C, and this has a funky name. It's called the hypotenuse. Now, you don't have to memorize that. You don't have to memorize that name. But what I do want you to remember is that the hypotenuse is always going to be the longest side. Guaranteed longest side. So now let's look back at this problem. We got a right triangle, Pythagorean theorem. We know what A and B represent. They represent the sides that make our right angle. And look at what we're given. We are given the longest side is 29. So that means this hypotenuse, which is always our longest side, guaranteed to be 29. So let me come to my formula, y'all. I'm going to take that 29, my longest side, which is C, and I'm going to take 29 squared. Now, longest side, 29, and one of the remaining sides is 20 centimeters. Don't stress about, do you let it be A or B? It doesn't matter. I underlined it in purple, and I got the letter or side B down here in purple. So I tell you what, I'm going to let that 20 be side B. So I'm going to put 20 squared for that B squared. Now, we got to find that other side. What is the third side? So in this particular case, we're still trying to find one of the shorter sides. The third side, I'm going to solve for A. So we still have this squared thing flying around. We are going to use the square root button right here in a moment. So let's bring down our A squared. 20 squared is 400. 20 times 20. And 29 squared, I don't know. 29 times 29, that's going to be 841. Now, I know some of us in here, there's a good chance, we have almost 80 people in here. I'm guessing around half of us are kind of iffy when it comes to solving equations, let alone when you start throwing exponents into equations. So, y'all, let's just suppose, let me get another color here. Let's just suppose this equation was A plus 400 equals 841. Let me just take away that squared for a second. If it was A plus 400, the only thing you would have to do to solve this equation is subtract 400 from both sides. That's right. That's right. That's all we would do here. We would subtract that 400 from both sides, and in this particular case, it would be A equals, and that would be 441. And I do see some of these answers coming in. So, you take the same logic. We're going to subtract the 400 from both sides, but it's not just going to be A equals. It's going to be A squared. So, A squared equals 441, and most of us probably don't know that off the top of our head, so this is where you can take the square root of both sides to get that A by itself. Now, you see how I was canceling out here and I was canceling out here because of the adding and the subtracting? Well, technically speaking, the square root and this squared cancel each other out. This is what truly gives you the A by itself. And then if we type in 441 first, then press the square root, we get 21. That is going to be our missing side. So here is our next question. What is the area of the right triangle? We'll do a minute and a half. Try it out. All right. So let's see. I was looking back over in the Facebook group. Some people are having trouble getting into the session, but I'll have to look at that in a minute. So, Miss Anna, 84, A. Yes, so A is the correct answer here. And what we're going to do, we have a right triangle, but we need to find the area of this thing. So this is another formula that you do need to know, just in case you are asked to find the area of a triangle. Now the area of a triangle is base times height divided by 2. Now some of y'all may have heard it referred to as 1/2 times the base times the height. But let me use words here. Base, height, divided by 2. So that B stands for a base here. And if you forgot to divide by 2, technically what you're doing there, you're treating that triangle as if it were a rectangle. And technically, y'all, check this out. I think you might like this. Y'all, if I come right here and let me just draw. Okay, look, I'm gonna start right here. Do y'all see the rectangle I'm drawing? What's the formula for the area of a rectangle? Length times width, or some of y'all may have heard of it as base times height. This triangle is literally half of that rectangle. That's why the formula, so if you call a rectangle a base and a height instead of a length and a width, all you're literally doing is taking a rectangle, base times height, but you're taking half of it. That's why we divide it by 2 for a triangle. Now, in this particular problem, we need to find this missing side, and this technically, we could call this our base. We can call this our height. And this right here, now I know we've called this A, we could call this B, and we can call this C, just like we did in the previous problem. All right, so let's do our formula. So we know our hypotenuse again, the C. We don't know our base. That's what we're trying to find. Now, by the way, y'all, why did I call this one the base? When I hear the word base, I just think what the triangle's sitting on, the base. And then the height just comes right up off of that base. It comes 90 degrees off that base. All right, so we don't know the base. And we do know A, 24 squared. All right, so let's square these things. What is 24 squared? That is 576. We don't know what B is. 25 squared is 625. And y'all, I mean, I kind of did this on purpose, I guess. You know, a while ago we solved for A. But I made a point to say it don't really matter which one you call A and which one you call B. We solve this the exact same way. Subtract 576 from both sides. But instead of us having A squared equals, now we have B squared equals. And let's see, if we subtract that, we're going to get 49. And isn't that one that we talked about earlier with the square roots, right? Take the square root of both sides. 7 times 7 is equal to 49. So that is the base of our right triangle. Now that we have everything we need now. We can now find the area of this triangle. Area is equal to that base, what the triangle sits on, 7, times the height of 24. That's how high the triangle goes up from the base. And then just make sure we come and divide this by 2. And what is that going to be? 84, that's right. So, you know, and it don't really matter how you type it in, 7 times 24, and then you can divide it by 2 all in one swoop. So we do get an area of 84 square inches. If you have a right triangle, so question was, I'm going to scroll back through some of these questions. I saw some of them coming in. So one question is, we always use the Pythagorean theorem formula. If you have a right triangle, that's your key word there. So if you ever see the word right triangle, there is a good chance, it's not guaranteed, but there is a good chance that you will likely use the Pythagorean theorem. I think that is it for the geometry piece. So obviously there's going to be more geometry on the TEAS. When do we just need to know the area of a triangle? Well, so Nicolette's saying, when do we need to know just the area of the triangle? If you're given the base and you're given the height, then you don't need to do any of this extra work. But we didn't know both the base and the height. But if you do know the base, you do know the height, you can just find the area of a triangle instantaneously. And then Victoria, longest side, always the hypotenuse, absolutely. And that's going to be right here. So that side that does not make the right angle. This green side back here, y'all, does not make this right angle down here in this corner. That's always called the hypotenuse. It's always going to be the longest side. All right, rock and roll. So now we're going to move on to what's next. Okay, proportions. Now, proportions are popular. A lot of people use them for a lot of word problems, and there's a reason, because you can use proportions for a lot of problems. But what I'm going to do is we're going to do proportions first, or you may just know when to multiply, you may know when to divide, or you may have your own technique. If you're getting the right answer, I don't care how you do it, but I'll show you one way. Let's do 1 minute on this one. Try it out. All right, so C is going to be our correct answer here. I snuck in a word on you, and some of you may have overlooked it, but $1.44 is how much a dozen gauze pads cost. So, proportions, we are comparing two things. So I'm going to get on this little train of talking about two things and more things a little bit later. So, we are comparing two things. The two things we are comparing are gauze pads and their cost. Look at that first sentence. A bulk order of 300 gauze pads costs $36. So those two things, we can create a proportion. Now, y'all, I know I'm going to get a bunch of questions about this, but look, I'm telling you, if you got the answer right, if you set up your proportion different, I've mentioned this in many videos, there are so many ways to set up a proportion correctly. I'm just going to show you one way. What we know is that 300 gauze pads cost $36. So I'm going to put 300 at the top of a fraction, and I'm going to put the 36 at the bottom. Why? Because I can. But you don't have to do it like that. And I'm going to set this equal to, and I'm just going to write a reminder here. What does that 300 represent? That represents the number of pads that we have. Gauze pads. And then what does this 36 represent? The 36 represents how much those 300 gauze pads cost. So what I'm doing here in my proportion is I'm putting the gauze pads at the top, the cost at the bottom. You might not have done it that way. It's okay. So now if we go back to our problem, the question says, how much does a dozen, that's 12, how much does 12 of these gauze pads cost? So this 12 is talking about gauze pads. Since I have that at the top, I'm going to put 12 at the top. The question says, how much do they cost? We don't know, so I'm going to put an X down here at the bottom. Proportions are fine when you're comparing two things. Now, let me show y'all the long-winded way of solving this, and then I want to go ahead and show all 70 plus of you how you can do this a little bit quicker to get back a few precious seconds on that test. Now, cross-multiplying is the common way to solve proportions. So, cross-multiplying, it does not matter which ones you cross-multiply first. I'm just going to do these two. So 300 cross multiplied by x is going to be 300x. We set this equal to the other cross product, whatever it may be. So in this case here, we have 36 times 12. 36 times 12 is 432. So we have yet another equation. And to get x by itself, because that's what we're trying to find, the question says how much does a dozen gauze pads cost? That's what x represents. To solve this equation, we divide by 300. This is going to get our x by itself. Now, why did I divide? Just to reinforce equations. This 300x means 300 times that x. And the opposite of multiplying is to divide. So 300 divided by 300 is 1. We don't even write that down. We get x equals whatever 432 divided by 300 is. That's $1.44. Now, if you picked A is the price of one gauze pad. But since we wanted a dozen, technically you could take the 12 cents times 12. Now, if you like proportions, I see a lot of got it. Great. If you like that way, great. I'm going to come at the end of our session tonight and I'm going to do this problem again and I'm going to show you another way to do it that's not proportions. But we're going to wait on that. So let's hit on this idea. Comparing two things, very popular technique to do with two things is proportions. Here is maybe another example. We'll do a minute on this one. Try it out. All right, 32. So look, if you're getting 32 and you're submitting it that fast, y'all, I just gave you a minute to do that question. So you are well under the average amount of time per question. So, this has nothing to do with gauze pads and money. We're talking about miles and gallons. That's what I want you to see here. We are comparing two things again. We have miles and gallons. And a lot of times, not every time, those two numbers that are kind of close to each other, notice the 468. Jack can travel 468 miles on those 18 gallons of gas. I'm going to do a fraction, 468 over 18. I'm doing it pretty much the same way I did it a while ago. Let's just remind ourselves, what does the 468 represent? That is our miles, 18 is our gallons. And I'm only writing those there for reminders. Of course, the more you practice this, you won't need to do that. Set this equal to. Now, what's the question saying? How many gallons of gas would he use if he traveled 832 miles? So I'm going to put 832 at the top since I had miles at the top over here. Put this over what? The question is saying how many gallons? We don't know. Now let me show you the fast way. I should have showed it to you a while ago. So maybe you can see both of these. But if we go and do our cross multiplying, it's going to be just like this. Let me jump back to this problem real quick, y'all. What I want you to do is try to do this a little bit quicker, and maybe some of you are doing this anyway. Y'all remember how the 300 was getting multiplied by x? Right? So that 300 was getting multiplied by x, and what did we end up doing ultimately to that? We ended up dividing by that number, right? Well, that's always true for these types of proportions. My point here is this. Whatever number is getting multiplied by x will ultimately be the number that you end up dividing by. So let me just do this problem again, and I want to show you how you can do this in one swoop and knock it out. I'm going to ignore the 300. I know I'm going to divide by it. Let me go ahead and multiply my other two numbers first, and then, boom, I'm going to press divide right now. And I'm going to type in 300, and you can just do it all in one calculation. This prevents you from writing down excessive material. This prevents you from, if you're writing down more stuff, you might copy it down wrong. So doing it all in one swoop. So check it out. Let's do that on this one. Which number do we ignore this time to begin with? I don't care about the 468. I know I'm going to divide by it, but I'm not worried about it right now. 18 times 832. Immediately divide by 468, and there's our answer. You just wait. Y'all just wait. If you like that, wait till I show you the dimensional analysis way of doing this. All right, so that's two things, and we've done completely different things. Gauze pads and money, miles and gallons. It could be boys and girls. It could be red marbles and blue marbles. Now, let's look at a scenario where maybe we have more than two things. I'm going to put 2 minutes on this. I'm going to get a drink refill, plus this one's a whole paragraph. So try that out. I'll be right back. All right, so do y'all see how we have more than two things here? I did an entire live session on this, and I'm reinforcing it for several reasons, and I'm going to talk about those. But B is correct, 57. And I know, Victoria, you mentioned you prefer dimensional analysis. That is probably how you did this, I'm guessing. And same thing to old Mom down there. I'm just going to call you Mom tonight. How about that? Now, notice we are comparing more than two things. We have, and this is true story, my son, he's actually kind of growing out of this phase now, but we got football cards, we got basketball cards, and we got Pokemon cards. There's three things. Now, you cannot solve this in a single proportion, because a single proportion only allows you to compare two things, just like we did in this previous two examples. You can only compare two things in a proportion. So we got to have another way. And this is where dimensional analysis saves the day. Now, I got some other videos on this. It's going to be a little bit funky to begin with, but I'm telling y'all, I think if you don't like it or if you've never done it, I might be able to convert some of y'all in these last several problems. Dimensional analysis is great when you are comparing multiple things. I don't care how many things you're comparing. And by the way, out of everything that I could teach y'all for the TEAS, with the exception of some of the conversions like milligrams and milliliters and stuff, this technique right here is how I teach med dosage. One technique for a whole med dosage, multiple semesters of med dosage. But anyway, so dimensional analysis. Well, a lot of times with math problems, how do we start? So how do we start? Well, ask yourself this. What are we trying to find? What are we trying to find here, y'all? We are trying to find, the question says, how many football cards, right? This will always work. Just bear with me here. So this is how you get the ball rolling. What are you trying to find? We're trying to find football cards, because that's what the question's asking right there. How many football cards does he have? So I'm going to create a fraction, and I am literally going to write the words in these fractions. Since I'm trying to find football cards, I'm going to put football cards at the top of this first fraction. Why? Again, I'm going to say it over and over and over. That's what we're trying to find. This is how you can start it off. So if we look back at our problem, we got to find some information that we know about football cards. It could be in any of these sentences. But right here, look at what it says. For every 19 football cards, Jackson has 93 Pokemon cards. So I'm going to put the 19 with the football, and those 19 football cards are getting compared to the 93 Pokemon cards. Notice I'm writing my words. This is what's important. Automatically, dimensional analysis, go ahead and multiply and write another fraction and put Pokemon at the top. And I cannot spell. Now, why are we doing this? It's going to be an automatic thing the more you practice. But by us putting Pokemon at the top automatically, this will let us cancel out these words. Well, we're putting Pokemon up there, but we got to find some information about Pokemon. Now, we don't want to use the 93 again. We've already used that. But we do have these 31 Pokemon cards. I'm going to put a 31. And what are those 31 Pokemon cards getting compared to? 14 basketball cards. And this pattern continues on. Now, bear in mind, y'all, the only thing we want is football cards. That's why I got rid of Pokemon. because we don't want Pokemon cards. Well, now we got basketball cards popping up. We don't want basketball cards. So what we're going to do is create another fraction. And guess what? We're going to put basketball at the top. This will allow us to cancel out the basketball words. And let's find one more piece of information. Jackson has 126 basketball cards, and I'm going to put this over 1. And what this 1 technically stands for is his one whole collection of cards. So out of his whole collection, he has 126 of them that are just basketball. Now, that word's not really important for you to understand there, but that's really what that 1 stands for. Now, so how do we know we're done? Well, for one thing, we've used every daggone number in this problem. I mean, I didn't underline this one, but we have used every number. And sometimes you will, sometimes you won't. There's no set way of knowing that. But what I want you to also notice is that we have gotten rid of all of the other types of cards. And the only type of card that we have not canceled out is the one we started off with, football. And that was the one that we're trying to find. Now, y'all, grab your calculators. I'm going to show you a nice one swoop way to get this answer. We're only going to press equals 1 time. And this will work when you're in nursing school too. This will work for your med dosage class. So grab your calculator. Whatever numbers you have at the top, you're going to multiply by them. So I'm going to type in, and I'm not going to press equals. I'm going to type in 19 times 31 times 126. Now, some of y'all might press equals. It's fine if you do, but I'm not going to. Immediately, whatever numbers you have at the bottom, we have a 93, we have a 14, and we can skip this 1. The 1's not going to change anything. 1, multiplying by 1, dividing by 1, it doesn't change anything. But whatever numbers you have at the bottom, divide by those numbers. And you can divide by them individually. So bear in mind, what have I done? I've typed in 19 times 31 times 126. I'm going to immediately divide by 93. I'm going to press divide again. I'm going to type in 14. And now I'm going to press equals. And we get 57. This is the fastest way to do this problem, in my opinion. Unless you're really, really good at logically thinking through things. If I wasn't teaching this, I would do it entirely different. But this is how I teach it. And I'm telling you, I'm glad y'all like it. Y'all just wait. We still got 3 more problems. But I'm telling you, if you learn this technique, you will crush your med dosage exams. I have worked with so many. That's going to be my next baby. I mean, right now, TEAS math is my baby. But I'm moving to med dosage. I'm not going to leave TEAS alone. Don't get me wrong. But med dosage, I mean, I've worked with so many people from developmental math through the TEAS, through med dosage, their college algebra, their statistics. I can help you with any math you need. Now, bear in mind, our Facebook group, the Facebook group is just for med dosage and TEAS, though. I don't want to throw a lot of calculus or statistics and stuff in there. So I bet you're itching for another problem where we're comparing multiple things. So here comes another problem. I call it the recipe problem. And we'll do 1:30 on this one. Try it out. All right, so here we are. And that was 1.5 minutes. So these are some of those problems that can take up that full average time. And y'all, there's going to be problems that take longer than 1.5 minutes. But here in this one, we are technically comparing 3 things. We have 3 things. What are our 3 things? Well, I see. So let's look at some things in here that have numbers. I see 1.5 pounds of beef. I see the 9 people. And then look at what the question's asking, y'all. It's kind of hidden, but we got packages. We got packages. Y'all see that? Y'all see what the question's asking? The question is asking, how many packages? So, just like a while ago, what are we trying to find? We're trying to find packages. So guess what I'm going to do? I'm going to treat it no different. Honestly, y'all, no different than football, Pokemon, and basketball. I know it don't have a daggone thing in common with it, but what I want y'all to see are the three things, the multiple things. So what do we know about packages, y'all? We know that the packages are 2 pounds. So watch what I'm going to do right here. I'm going to write 1 package over 2 pounds. So again, the question says how many packages. That's what I'm starting off my problem with. I go back in my problem and I find some information that I know about packages. They are 2 pounds of beef. So automatically, let's build that habit. The next fraction, we're going to put pounds at the top. Well, what do we know about pounds? We got 1.5 pounds. Now, y'all, we can't always count on both of the numbers being in the same sentence. So, you know, a little bit of English and reading and whatnot here. A recipe for a pot of soup requires 1.5 pounds of beef. That 1.5 pounds of beef will serve 9 people. So we're going to put the 9 people at the bottom. Now that could have easily been in one sentence, but it wasn't. But we're still comparing the 1.5 pounds that will serve 9 people. So we can cancel out our pounds. Now we have the word people. So let's go through here and let me just change my color. And we know that we need to serve 72 people, as you can see right there. And that's what's going to let us get rid of the word people. And this is a party. So it stands for the one group of people, the one party, whatever. We've gotten rid of the words we don't want. We've gotten rid of pounds. We've gotten rid of people. The only word we have left is package. Try that same calculator tip. Anytime you see ones, skip it. So my number's up top. I'm going to skip that 1. Don't need to do it. I'm going to take 1.5 times 72. And then you can press equals if you want. But remember what I did a while ago. Immediately divide by your bottoms. That's a 2. And then I'm going to divide by my 9. Bam, we get 6. 6 packages. So that's dimensional analysis. That is what if you continue to follow the stuff I provide, that's the way I teach med dosage. There are many other ways to do it too. I mean, honestly, if I was doing this by myself, I would not do dimensional analysis. Now, if this is your first time seeing this, I would still recommend you learn it. Go to my website. Remember how to search for keywords. Type in the word dimensional. You don't even have to type in dimensional analysis. And I have an entire other live session that I did, I don't know, last year or something, where I did some other dimensional analysis problems. It just takes practice. So don't beat yourself up if you're not getting it on your first shot. It takes practice. All right. Now, the last 2 questions are going to be the same 2 questions we've already done. But I want to show y'all dimensional analysis. I want to try to give you more practice. So it's going to be the same problems again. Look at number 10. So we're looking back at proportions, but we're going to do it with dimensional analysis. You might say, oh, well, we don't have 3 things. You can be comparing 2 things, 3 things, a million things. Dimensional analysis will take care of it. So what is the question asking? How much does a dozen gauze pads cost? We are trying to find something, a cost. So you can put the word cost if you want, but since we're trying to find a cost, I'm just going to put, a dollar symbol, because that's really what cost represents, money. So I'm not going to do a proportion, y'all. Watch, dimensional analysis does this very quickly. What's something that we know about cost in our problem? We know that $36 in our problem, that will get us 300 of these gauze pads. What word do we need to get rid of? We need to get rid of the word gauze pads. I just shorten that up so we can cancel out the gauze pads. And what do we know? What's some other information that we know about our gauze pads? There's a dozen of them. So I'm going to say 12 of those pads. And we don't need to do any more fractions. I'm just going to put it over 1 for decoration. This is dimensional analysis, but we only had to get rid of one thing. 36 times 12 divided by 300. Let's see what we get. $1.44. And why is this $1.44? Why am I putting that dollar symbol in front? Because there's a dollar symbol. That's what we're trying to find. That's the only technically word. I mean, if you want to write the word cost, that's fine. But I'm just going to use the dollar symbol. Y'all see dimensional analysis there? Whatever you're trying to find, start off with that at the top. Now, there are other ways of doing dimensional analysis, but this is the way that I teach it. And the more you practice it, it's going to stick like super glue. What are we trying to find? Start off your problem with that. And to reinforce that even more, check this one out. This is Jack again. If Jack can travel 468 miles on 18 gallons of gas, how many gallons of gas would he use if he traveled 832 miles? How many? How many? How many? These questions are asking how many football cards, how many packages, how many money, how much money. But are y'all seeing a trend here? So how many gallons? I'm going to start off with gallons. And why did okay, I know I put 18, but why did I put, that's the only thing in this problem that mentions gallons. But since I'm trying to find gallons, that's why I'm putting that word at the top. And that's the only time gallons is mentioned. And what do we know about these 18 gallons? We know that Jack went 468 miles. Automatically, next fraction, put miles at the top. And the only other thing is that 832. What do y'all think? 18 times 832 and then immediately divide by 468. There you go. 32 what? 32 what? The only word we have not canceled out is the word gallons because that's what we're trying to find. Technically speaking, dimensional analysis can do every single proportion problem. And yeah, so have a great weekend. Y'all take care. Good night.